Hi children, today's topic is refraction of light. So far we have seen reflection of light, okay? Reflection of light by mirror, that is spherical mirror, plane mirror, everything we have seen, and we solved some problems also there, okay? Now the other, what is that phenomena, what is called refraction of light we are going to see. What do you mean by refraction of light? See, you know that we have seen the light travels in a straight line path. We have already seen, okay? Light travels in a straight line path, but as long as it is traveling in the same medium. As long as it is traveling in the same medium. What do you mean by medium here? Medium means, what is that? Air is a medium. Air is a medium. Okay? Then water, it is a medium. Glass, it is a medium. Oil, it is a medium. Okay? So, as long as it is traveling only in air, its path will be a straight line. As long as the light is traveling only in water, happily it travels in a straight path. Okay? Therefore, which means as long as it is traveling in the same medium, okay, it is, what is that? Following a straight line path. But what happens all of a sudden when the light enters from one medium to another medium? When it goes from one medium to another medium, then what happens? All of a sudden it is, what happens? It is going from one medium to another medium. For example, air to water or glass to water. Okay, whatever is that, one medium to other medium. What happens? Okay, all of a sudden when it enters, it changes its path. Okay, it changes its path. It won't be a straight line. There will be some, it deviates from its original straight line path. Okay, as long as, for example, it is, what is that? It is going from air to water. Light goes from air to water. In air, it is moving in a straight line path. Okay, when it enters into water, it suffers some change in its path. It deviates from its original path. Okay, so this phenomena, okay, of what is that change in the path of the light when the light goes from one medium to another medium is what is called refraction of light. Are you following? Therefore, what is refraction of light? Refraction of light is the phenomena of change in the path of light when it goes from one medium to another medium. Hope you are following. Okay, what is refraction? Once again, I'm telling you have to take a note. What is refraction of light? Refraction of light is a phenomena of, it is a phenomenon of change in the path of light when it goes from one medium to another medium. Okay, right. Now, therefore, this is what is called refraction, right? Now the question is, why? Why is it changing its path? What is, see, it is changing its path. What is the reason for that? What is the cause of refraction? Now we are going to see. Therefore, cause of refraction of light. Okay. What is the cause of refraction? See, now we have seen what is refraction of light. Definition I have told you. You have to take notes. I won't write here. Okay. Cause of refraction of light. What is the cause of refraction of light? Very, very important. See, the refraction of light occurs. Okay. Because, what is the reason? Because speed of light changes when it goes from one medium to another. That's it. Okay. So, why refraction? Why there is a bending? Why there is a change in the path? Okay. It bends. When the light travels from one medium to other medium, it changes its path, means it bends. Why is it bending? What is the need for what is the change in the path? Why? Because there is some, it suffers some, what is that? Change in the speed of light. Change in its speed when it goes from one medium to another medium. Are you following? So, the refraction of light occurs because the speed of light changes when it goes from one medium to another medium. Okay, therefore whether the speed will increase or decrease, immediately the question will arise. Its speed changes means whether the speed will increase or decrease when it goes from one medium to another medium. That is a very important question. Huh? So here, speed of light depends very much on okay, on what is called optical density. Of medium. What do you mean by optical? See, you know that density as what is called mass density, you know. I think you would have studied in your 9th standard. Mass density, just like the density. You have studied what is density. Density is nothing but mass by volume. You would have studied, no? Mass by volume. It is what is called mass density. Okay, but here it is what is called optical density. Optical density very much depends on optical properties of the medium. It is not mass density. That is different. Optical density is different. That depends very much on optical property of the medium. Okay. Therefore, now what is that? When the light is traveling from one medium to another medium, okay, as I told you, there will be some change in the speed. Okay, speed of light, therefore, how the speed changes, whether it is increasing or decreasing, that very much depends. Speed of light depends on the optical density of the medium. Optical density means that is, it depends on the optical property of the medium. For example, I am giving you. Let us consider the light. The light is traveling in air medium, and after that, what is the light? It travels in water, and light travels in glass. Okay. Therefore, if you see the speed of light in these three media plural, okay. In air, you know very well it is vacuum or air. The speed is 3 into 10 power 8 meter per second. Correct? Okay. This is the maximum possible speed of light. Light travels with its maximum speed only in air or vacuum. But what is the speed of light in water, if you see? Okay, therefore speed of light in air and speed of light in water and speed of light in glass. Okay, if you see, it is, what is that? For air it will be more, and water it will be more than that of glass. Speed of light in glass, here of these three medias we have chosen, air, water and glass. What is that? For glass, it is, the speed is least. Okay, next one is water, more than that is water, and speed of light is maximum in air. Are you following? Therefore, okay, therefore, now how do you relate it to the optical density now? You know, what is that? Air, the speed is more. Okay, speed of light is more. Speed of light is, next one is water, and speed of light here out of this three it is least, right? Therefore, which means that, how can you relate this speed to optical density? It is saying that optical density, okay, so optical density of air is least than optical density of water, and it is more, which is the maximum? Optical density of glass. Okay, so optical density, if you compare optical density of glass. Okay, so Now if you compare, more the optical density, less will be the speed of light. Are you following? Is it clear? Therefore, now I am going to give you one more. This one, see, depending upon the optical density. Now you know what is optical density. So, if you take only air and water, okay, here what is that? Optical density of air is what is that? Here, optical density of air is less when compared to that of water. Now, I am taking only these two now. These two. Okay, therefore you know that, okay, V of air is more when compared to V of water. Therefore optical density of water is more than the optical density of air. Okay, is it clear? Therefore out of these two media, I have taken two medium only, air and water only. Okay, out of air and water, you can say this air medium is what is called a rarer medium, and water is what is called the denser medium. Are you following? So, more the optical density, okay, if the out of these two, air and what is that, water, optical density of water is more. Therefore out of these two, water is considered as a denser medium in comparison with air. Are you following? I have taken two media. Okay, like that, if you take these two, water and glass, see, water and glass, it is seen that, you know, the optical density of glass is more when compared to water, correct? Out of these two, water has less optical density when compared to glass. Therefore, out of these two, if you in comparison, you can say water here is a rarer medium. It is relative only, okay? And glass is nothing but a denser medium. Are you following? If you take any two medias, then you can say one out of which, what is the one is rarer and out of the other one is denser, depending upon their optical density. Okay, so more the light travels, therefore you can say light travels faster in rarer medium, correct? Out of these two, air and water, which is rarer? Air. Therefore, velocity, speed of light in air is more when compared to speed of light in water. Therefore, like that in these two, water, glass, rarer is water. Okay, therefore, what is that? Speed of light in water is more when compared to that in glass. Therefore, how to conclude it? Light travels faster in the rarer medium than in the denser medium. Are you following? And when the light goes from, okay, are you following? Rarer to denser medium. When the light goes from rarer to, are you following me? This is clear. Therefore, what is that? Light travels faster in rarer medium than in the denser medium. Therefore, now, are you following? When the light goes from rarer medium to denser medium, rarer to light, okay, travels or goes from, okay, travels, goes from rarer to denser. Okay, rarer to denser medium, then, okay, what happens? When the light goes from rarer to denser medium, speed decreases, no? Why? You know, in rarer medium, it moves faster when compared to denser. Therefore, when the light is going from rarer to denser, definitely speed decreases, right? And these are all very important concepts, okay? When the light goes from denser to rarer, denser to rarer, rarer what? Rarer medium. Rarer medium. Okay. then what happens? Speed increases. Okay, light goes from denser to rarer means speed increases. When the light goes from rarer to denser means speed decreases. Are you following? Is it clear? Okay, right. With this, we'll go to see. Therefore, now I am going to give you, see, I have therefore, what is that? Because it, how it changes its path now, it's a question. Okay, now we know very well which is rarer medium, which is denser medium, comparison, everything you know. And you know very well speed, how it changes from, when it goes from one medium to another medium also, you know. Now, how it bends then? I told you, refraction of light is a phenomenon of change in the path of the light. Change, it deviates from its original path now. So, how it bends, how it changes its path. Now, it is a question. Now, we will see. Okay. Now, the first one. Okay, example is, let us consider two, actually, I have, let me have some color, different color. See, I have two medias. Okay. Now, see, listen, very important. Now, we are going to see how the light is going to bend. Okay. This is the interface. Interface mane kya hota? Okay. It is an interface connecting, separating two media. Okay. Therefore, this medium, for example, this is the air medium. This is the air medium. And here, this is water. Are you following? This is water. This is the water medium. And that side, upper portion, it is the interface. This is what is called interface. Interface means that is which separates two media, air from water. Okay, hope you are following. Right. Now, light is falling. What is that here? The light falls like that. This is the path of the light. Okay, this is entering. It is going incident light. This is incident light now. Therefore, this is the incident light. Incident light is in which medium? This is the first medium. See, where the medium in which incident light is there, it is what is called the first medium. And okay, it falls here. It is moving in a straight line only now, and it falls at the interface because it is now going from air medium to water medium. Are you following? Therefore, now I need to draw at the point of contact. Here is only it is touching the interface now. Okay, there you draw a normal. You draw a normal. Normal means what is that? Perpendicular now. So this is the normal. Okay. So what happens? Actually, if there is no change in the medium, the light will be traveling. The light has to travel in a straight path only like that. It should follow like that only. It should follow like this. But now, because there is some change in the medium, it goes from air to water. When it goes from air to water, air is which medium? In comparison, air and water, which is rarer? This is the rarer medium. And this is the denser medium. Correct? So, the light is going from air to water means the light is going from rarer to denser medium. Rarer to denser medium means the speed will decrease. Just now we have seen. When the speed is decreasing, then now how it deviates from its original path? Actually, it has to follow like that. But now, what it does, it is bending. Instead of going, actually, this should be the original path, but it won't move like that. But what it does, it bends. It deviates from its original path. How? It bends towards the normal. It bends towards the normal. Instead of going like this is the original path. It won't move in that. But instead what it does, it bends towards the normal. Therefore, this is your refracted light. This is your refracted light. Are you following? Therefore, when the light is traveling from rarer medium, so how to generalize? When the light is going from rarer to denser medium, it suffers some decrease in its speed, correct? Okay, due to which it bends towards the normal. It bends towards the normal. Okay, now next one. The next case is, see, the same ulta. I will take the same medium, but see here, what is that? This is the interface. Okay. Now, the light is traveling now from water to air. This is water. So, are you following? So, which is the, here it is the first, in this case, in the first case, this is the first medium and this is the second medium, correct? Second medium. So, but here the first medium is what? Water. And the second medium is air. This is the second medium. Therefore, you can say that water in comparison, water and air, which is denser, water is denser. Therefore, this is a denser medium. But here it is a rarer medium. Are you following? Now, the incident light is in the first medium is, what is it here? First medium, which is the first medium? Water. So, here this is the incident light. Okay, this is the incident light, right? Now, it is the green one, that line is the interface. Okay, therefore, now you draw the normal. This is the normal. At this point, where it touches the interface, there you have to draw the normal. Normal means perpendicular. Okay, this is the normal. Now, what happens? See, it is going from denser to rarer, water to air. Therefore, what will happen to the speed? Speed will definitely increase, correct? Speed will increase. So, actually, original path क्या होता है इसमें? This is the original path. But what it does, speed is increasing now. Speed is increasing. Therefore, what it will do, let me just slightly, because the incident light I will go for. This is the incident light. Okay. So, so what will happen? This is the interface. Okay. Now what happens? The incident light actual path is like this. It has to move in this direction only. But what it does, instead, it slightly, okay, it goes away from the normal, away. Instead of going, it goes like this. Are you following? What is the, see, here it is actual path. In the first case, this is the yellow dotted line, hai, that is the actual path. Okay, but it won't go in the, after it won't follow the same straight line. It bends, it changes its path. How it changes? Bends towards the normal. But in this case, what is that? It is straight line path. Here, this is incident. This is the incident light. Okay, and this is the dotted line is nothing but its own. What is that? The original path. This is the original path. But what? Because it is going from where denser to rarer. Okay, it suffers some increase in its speed, so it bends away from the normal. It bends away from the normal. So, for this is your refracted light. Okay, so can we now conclude? Now, what is the conclusion from that? When the light goes from rarer to denser medium, it bends towards the normal. And when the light goes from denser to rarer medium, it bends away from the normal. Bends away from the normal. Okay, but one more thing is also there. What is that? When the light when the light, let this be any medium, therefore see here, okay, let it be a water, okay, this is water medium, okay, third case, and here it is air medium, okay. Now this is first medium and this is second medium, right? But now you see, okay, the light is, it is a normal, okay, this is the normal. When the light is traveling through the normal, along the normal, now here it is a light, and the light is traveling along the normal, let me draw the light with okay, the light is overlapping, it is traveling along the normal here, this is the interface point at the interface, this will be the normal, along the normal. When the light is traveling, there is no change in path. Here, what is in this case, when the light, okay, here from this, when the light travels from rarer to denser medium, it bends towards the normal, correct? It bends towards the normal. But here, next one, when the light travels from denser to rarer medium, okay, it bends away from the normal. It bends away from the normal because there is some change in the path. Okay. Third one is when the light travels, okay, travels along the normal, whether it is from rarer to denser or denser to rare, doesn't matter. When the light is going along the normal, okay, then what is that? No change from one medium to another medium, along the normal, from along the normal, from one medium to another. One medium to another only I told, whether rarer to denser or denser to rarer. Okay. Whatever is that, when it travels, no, this is the normal na. Okay. So light travels, it is the normal, and this is incident ray. It is okay. So it is traveling along the normal. This is nothing but the refracted. Okay, you can say it is, what is that? Are you following? This is by incident ray. When it travels, what is that? Along the normal. When the light travels along the normal from one medium to another, no change. It suffers. Okay. What is it? No change. No change in its path. No deviation at all. It travels the same. Is it clear? So these are all the very important concepts that you should know here. Okay, right. Now with this, once you know this, we will go to, okay, the next topic is law of refraction. Laws of refraction we are going to see. Okay, laws of refraction. Okay, very important. See, when the light goes from one medium to another medium, for example, see, let me take the same, okay, I'll take a medium like, okay, let me go for, um, this is the interface, okay, this is, okay, let it be, no problem, but interface I want to give some other color, different color. Okay, this is water, okay. Okay, now this is glass, let it be this is glass, any color, okay. Okay, so I have two medias here. One is water, the other one is glass. Here it is water and this is glass. Okay, right. Now what happens? The light, this is the first medium and this is the second medium. The first medium here is nothing but the, in comparison, water and glass, which is rarer? Water, correct? Therefore, it is a rarer medium and it is a denser medium, correct? Water, glass, out of this relatively, out of water and glass, glass is denser, water is rarer. So now, what happens? See, listen. Here, the light is traveling now from water to glass. First medium means incident light is in the first medium. Second medium means it is a medium where the refracted light is there. Okay. So, the first medium, the light is traveling. This is the incident, right? Okay. Okay. So, it moves in a, okay, it travels like this. Now what happens at the interface here? Okay, so what I have to draw the normal here. Therefore, let it be the normal. Okay, normal. So it is going from rarer to denser. Therefore, the light travels. What is it? It suffers a deviation towards the normal. Correct? So this is the incident. It is the incident ray. Once again, I am writing everything. It is the incident ray, and this is nothing but the refracted ray. Correct? Ray. Refracted ray. Light. Refracted. Okay. Therefore, now, what is now the angle between incident ray and the refracted ray? Incident ray and the normal. Just what we saw in our law of reflection, no, like that. What is the angle between the incident ray and the normal? Let it be that is, instead of what is the angle between the incident ray and the normal is I. Okay, let me go for some other color, bright colors. The angle between incident ray and the, okay, let me yellow. This is I, let it be. And the angle between the refracted ray and the normal, this one, this is R. This is R. Are you following? So, therefore, now what is law of first law of refraction? First one. Okay, it says that. Okay, this is the first one. Okay, the same I will okay, for with this diagram first, because the light is going from rarer to denser. After that, we'll go the other what is that, pair also. First with this one we will see. I am going to give the statement for law of refraction. What is that? It says that the ratio of sine of, I think trigonometry you people are studying, sine, cos, cosine, everything. Therefore sine of angle of incidence, that is nothing but sine I. It is called sine I, angle of incidence. Okay, and the ratio of sine of the angle of incidence and the angle of refraction, that is sine R. Okay, is a constant. The ratio is a constant. It is a constant. Okay, but with a condition. It's constant for a given pair of media. What do you mean by pair here? What is a pair? Water, glass. For this pair, the ratio between sine of the angle of incidence and sine of the angle of refraction is a constant. If the pair is changing, the constant value will also change. That is the reason. Okay. Therefore, the ratio between, the ratio of, a ratio between. Okay. Therefore, the ratio between or ratio of the sine of the angle of incidence and the angle of refraction is a constant for a given pair of pair of media and for the given color of light. Color, or even you can say wavelength. Color of light. Different colors, they have different wavelengths. Okay, the wavelength, I think last year in sound and all you would have studied wavelength. Okay, so here light also has wavelength, but how light means visible, light means what is it, you can see different colors, therefore wavelength is denoted by which, what is a lambda. Okay, so lambda, if you see red color means it is more, wavelength is more, wavelength of red color is more. Okay, then wavelength of violet, so, and wavelength of green. Different colors will have different wavelengths. So here, as long as you are using the same color, okay, then you can say sin I by sin R is a constant. Are you following? Therefore, the ratio of the sine of the angle of incidence and sine of angle of refraction is a constant for a given pair of media. The pair you should not say water, glass. Okay, and for the given wavelength of light. Wavelength of light means what is the color of light. Are you following? Therefore, with this, let me go for, therefore, sin I, that is mathematically, sin I by sin R, ratio na, sin R is a constant, the constant is named as n21, the constant value is what is the n21. What is it? Now only very important, what is n21? Okay, now I am going, this is a constant. The constant is what is called, it is denoted by n21. Okay, therefore what is it? Here n21 is what is called the refractive index. This is a very important, what is a concept? A term here. It is refractive index. Index of the second medium. Which is second medium, glass. Correct? Here in this example I am telling. In this example, which is second medium, glass. Okay. Therefore, refractive index of the second medium with respect to first medium. Are you following? So, what is that? It is the refractive index of the second medium with respect to first medium. In the above example, if you apply this law is what is called law of refraction. This is what is called Snell's law. That is what is called Snell. This is what is called Snell's law. Okay. So, if you apply Snell's law here in this case, okay, therefore sin I by sin R is nothing but, in this case, if you find what is a sin I by sin R, apply Snell's law here. Sin I by sin R will be equal to refractive index of second medium, which is a second medium glass, with respect to the first medium. What is that? Water. Are you following? So, same thing. What I did is second here in general. It is okay, sin I by sin R is equal to n21, second medium with respect to first medium. But this way, what is the second medium is glass, first medium you know very well it is water. Therefore, I can write that is nothing but what is n21 na? N21 can be written as, what is that? Refractive index of glass with respect to water. Second medium with respect to first medium means it is glass with respect to water. Are you following? Therefore, this is what is called the law of refraction, that is Snell's law. Okay. Then there are two laws here. The first one is, what is that? The ratio between sine of the angle of incidence and the angle of refraction is a constant. Okay. Now I'll go for second one. What is the second one? Is like your initially we have seen law of reflection also. Incident ray refracted ray and the normal incident ray, refracted ray and the normal all lie in the same plane. Same plane. Last time I think I told you. Same plane. Well, how? It is the incident ray. Okay. And this is the refracted ray. From denser, rarer to denser means it is the refracted ray. And this is the normal. This is the incident ray and this is the refracted ray and this is the normal. All they lie in the same plane. Okay. So, same plane means what is that? It is xy. It is x direction. X, I think graph you would have drawn na x and this is y. Therefore, incident ray, refracted ray and the normal all lie in the same plane. Okay. Then, next one is we will see two for example now. Okay, if you are this is a refractive index of the second medium with respect to first medium. Okay, now next one is let me take the other okay, hope you are following this. Is it clear? Okay, so now if I am taking the other example now, see, if the light is traveling from, next example, the light is traveling from, okay, it is from glass to, what is that? Glass to water, glass to water. Therefore, see, the light is traveling from glass to water. Okay. Now, see, here, this is the interface. And this is water. Okay. Right. Now you tell me what will happen. See, this is the here normal Therefore, the incident ray here, this is the incident ray. Okay, here it is, this is, what is a glass, right? Therefore, it is glass. This is glass and this is water. This is glass and this is water. Therefore, okay, this is the incident light. Incident ray is going from denser to rarer medium now, right? This is the denser medium and this is the rarer medium. This is the first medium and this is the second medium. Therefore, the light is actually what will happen, the light goes and it will go away from the normal now after refraction, because it's going from denser to rarer. Therefore, slightly it will deviate away from the normal. Okay, therefore actually it has to go like this, but it goes away from the normal. Therefore, this is I and this is R. Correct? Therefore, if you apply the Snell's law here, I am going to apply Snell's law here. Therefore, you tell me sin I by sin R, that is equal to refractive index of the second medium with respect to first medium. Now, what is that? Is refractive the second medium क्या होता है इसमें? Water. And first medium is glass. Are you following? So, this is this NGW. This is what is called, I told you, refractive index of the N21 is called refractive index of the second medium with respect to first medium, I told you, no? And therefore, this is also named as, it is here, it is what is the refractive index of second medium क्या है? Water, okay, with respect to glass, correct? This is refractive index of water with respect to glass. Therefore, this is what is called, this is also called as relative refractive index. Why it is called as relative refractive index. That is what is that? It is a refractive index of one medium with respect to the other medium. Okay, the first, therefore, this is what is called relative refractive index. Okay, but now relative refractive index, what is it? It is between water and glass. Okay. Now it is it is relative refractive index of water with respect to glass, and the first one, it is, this is what is called relative refractive index of glass with respect to water. Both are called as, what is it? Is called as relative refractive index. Hope you are following, right? Now I want to go for one more. I want to give you the, see, the if your the first medium is there, no? The first medium is here in the first case, the first medium is water, and in the second case here, this case, the first medium is glass, right? Now I am going to take the first medium as, okay, listen, very important, air medium. The first medium is the medium 1 is what is called air medium. That is definitely air medium is, it has to be rarer medium when compared to any other medium. If it is a glass, if it is water, whatever is that, this is what is called, it is the rarer medium only. Next, therefore, next one, this medium, the next medium, second medium, yes, for example, if it is water, okay, if it is water. Therefore, you can say here the light is this is water medium and this is the second medium. Therefore, now what happens, the light is coming here, okay, and say, and the light is traveling from air. So this is the first medium is air medium, okay, and what is the second medium? Second medium is a water medium, Okay, therefore it is going from rarer to denser. This is a denser medium na. Therefore rarer to denser. Therefore it will go towards the normal, bend towards the normal. Therefore it is going like this. Correct? Therefore now this is the incident ray and this is the incident ray and this is the refracted ray. You draw, see, it is the incident ray and this is your refracted ray. Okay, therefore now this is I and this is R. Now if you apply Snell's law here, see, this is a ray. Ray means you have to draw with a very sharp pencil. Okay, therefore it is, therefore now I have some, see whether you are able to see this. It is not very thick. See. Okay, this is the normal and this is your incident ray. Okay, this is the reflection. Therefore now incident ray, after being, it is going from, see, there is some problem with it goes towards the normal instead of going like that. It's a slight bending towards the normal, I think. Okay, therefore now if you apply Snell's law here, sin I by sin R, see it, sin I by sin R, that is nothing but refractive index of second medium with respect to first medium. That is nothing but refractive में second medium क्या होता है इसमें? Water with respect to air. First medium is air, no? That is very, very important. First medium is air. Therefore, it is refractive index of water with respect to air. Okay, therefore this is, the first medium is the air medium means, then you can say this is what is called, this is what is called absolute refractive index. Absolute refractive index of what? Index of water. No need to write with respect to air. See, if the first medium is other than air, like in the previous case, you see, the first medium is glass, second medium is water. Therefore, you can write this NWG. Okay, that is what is that? N, refractive index of water with respect to glass. That is a what is a relative refractive index. But now if the first medium is air medium, okay, therefore refractive index of a second medium with first medium here, that is nothing but refractive index of water with respect to air, and that is what is called absolute refractive index of water. Okay, therefore this, in this case, I can write sin I by sin R is nothing but NW. That is enough. I can stop with NW. If I stop with NW, it says that first medium is air. That is, but here I cannot, in this case I cannot stop because it is some other medium, glass. Therefore W here, are you following the previous case? NWG. NWG. G is very, very important. Why? Because it is refractance of water with respect to glass. But here it is the first medium is the air medium, means then you can write it as NW itself you can write. Therefore that is what is called absolute refractive index of water, or simply you can say that it is refractive index of water. Refractive index of water. That says that the first medium is air. Okay, just a refractive index means that is absolute refractive index. That says that the first medium is a air medium. Are you following? Hope you are following. Is it clear? Like that, what is that? What is Ng? Ng mone kya hota? Ng means what is that? It is nothing but refractive index of glass. That is nothing but absolute refractive index of glass. Okay, which means that the first medium is the air medium and next second medium is a glass medium. Are you following? In this case, what is a refractive? It is what is called absolute refractive index of glass, or it is just a refractive index of glass. Are you following? Is it clear? Okay. Therefore, okay, now let us go back to this. What is n here in this case? Okay, only one I will take. Okay, here. Okay, in this case, what is the first medium is glass, second medium is water, na? So you can say that once again I am coming back from here, I am coming here. Okay, after giving you what is absolute refractive index, I am coming back to the previous one. What is that? Here sin I by sin r, that is equal to n21, that is equal to, I want to, it is, what is that? It is a refractive index of second medium with respect to first medium. Okay, this is what is called the relative refractive index. I want to express the same with respect to, see, relative refractive, I am expressing sin I by sin r with respect to relative refractive index, but I want to write with the absolute refractive index. How to write? That is nothing but n2 by n1. That is nothing but n2 by n1. What is that? Absolute refractive index of the second medium divided by absolute refractive index of the first medium. Are you following? That is why I have given you, now you know what is absolute refractive. What is absolute refractive index of a medium here is nothing but when you will get only the first medium is the air medium. Okay, therefore you will be, are you following? Therefore NW is nothing but NW, first medium is air. Ng means N, second medium is glass, first medium is air. Okay, like that. Therefore, that is what is called absolute refractive index, or simply you can write that refractive index of glass. Okay, now I want to express Snell's law, sin I by sin r is equal to n21. We stopped with that. Now I want to express in terms of absolute refractive index also. Therefore, that is nothing but n2 by n1. That is nothing but absolute refractive index of second medium divided by absolute refractive index of, ये तो second medium है, ठीक है ना? वो third medium लगता है क्या? Okay, it is second medium and it is for first medium. Are you following? Are you following? Therefore, in this case, I am coming here. Okay, here what is that? N sin I by sin r, that is equal to NWG, na? If I want to express in terms of what is that? Absolute refractive index, which is second medium here, water. Therefore, NW divided by NG. NW divided by Ng. Are you following? Therefore, sin I by sin r is equal to n21, that is NWG, that is equal to NW by Ng. Okay, is it clear? Hope you are following me. Okay, therefore, what is, if I want, okay, is it clear? Like that, if I come here, NWA, if I want to represent in terms of, that can be written as NW divided by NR, no? Okay, NWA is nothing but NWN21. That is nothing but NW by NR. That is nothing but NW divided by NR is 1. Refractive index of air is 1. Okay, therefore that is simply NW. That is simply what is called air. That is why I told you NW air means it is nothing but NW only. You know, it is, if I want to express relative refractive index, N21 is nothing but N2 by N1. क्या ना? N2 क्या है इसमें water in this case. N1 क्या है? Air. Therefore NW by NR. NR is equal to 1. Therefore you will get only NW. Therefore you can get, that is why you can NW air, instead of writing you can write just like that NW. That means that it is an absolute refractive index of water. Are you following, children? Is it clear? Therefore, let me generalize now Snell's law. Is it clear? I hope you're following me. Okay. Therefore, now I am going to give Snell's law once again. Snell's law states that, okay, what is that? Sin I by, let me give some other color. Okay, let me go for green. Okay, sin I by sin naught, that is equal to, generalize, I no air medium, no what, nothing, I am going to the second medium, first medium, like that. Okay, that is nothing but n21 है ना, refractive index of the second medium with respect to first medium ना, that is nothing, this is a relative refractive index ना. Now I want to express in terms of absolute refractive index, therefore that is n2 by n1, correct? n2 by n1. Are you following? This is nothing. n2 is absolute refractive index of the second medium. n1 is absolute refractive index of the first medium. Okay, absolute refractive index means, I think the first medium has to be air. Okay, that is okay, that is fine. Okay, but I want to express, you know very well, it is a law of refraction after all, Snell's law. So refraction occurs only because of change in speed, na? Change in speed in the both in the medium. Therefore, I want to express same Snell's law with respect to speed in both the medias. Speed in both the medias, how? Let if v1 is the speed in first medium, speed of light in first medium, and v2 is the speed of light in second medium. Okay, therefore I want to express the law of refraction in terms of speed also, because speed is a very important factor. Because of change in speed, when a refraction occurs, so I need to express Snell's law in terms of speed of light in both the media. Therefore I can write sin I by sin r is equal to n21, that is equal to n2 by n1 is equal to v1 by v2, that is equal to v1 by v2. Are you following, children? So what is that? I have represented sin A by sin R in terms of absolute relative refractive index, okay, of both the media, absolute refractive index, and also the speed of light in both the medias. Are you following? So this is Snell's law, the complete representation of Snell's law. Okay, today it is enough.